we can write 1/8 as 8 to the negative 1 power. We can also write 1/8 as 2 to the negative 3 power, right? Okay, what about 16? What two ways can we write 16 as a power? 4 squared or 2 to the 4th, right? Those are both equal to 16. Okay. How about 27? What can we write 27 to the power of? 3 cubed. 3 cubed. Could we also do 27 to the 1 power? I mean, yeah, could we also do 1/3 to the negative 3 power? Yeah, there's lots of ways we can write them, right? But that's just what we're looking for. So I'm going to give you a few minutes to talk with the person next to you, someone around you, and fill in the rest of these. All right, so 1/9. We can write 1/9 as what? 9 to the negative 1 or? Right, 3 to the negative 2. Could it also be 1/3 squared? Yes, right? So there's lots of ways you can think of it. 27, 3 to the negative 3. I also saw 27 to the negative 1. What about 1/2? 2 to the negative 1 power. 5. 5 to the 1. Chloe put, whoa, 25 to the 1/2. That's some good thinking. The problem is we don't really like fractions, so we're not usually going to want to write it with a fractional exponent because then we have to deal with fractions, right? But that is still very true. And could we also say 1/5 to the negative 1 power? What about 64? 64 is 8 squared. 4 cubed, 2 to the 6th. Also 64 to the 1. What about 1/25? 25 to the negative 1 power? And 5 to the negative 2 power, right? There are two ways we can write 1/25. Now 1. 1 has infinite possibilities, right? 1 to any exponent is equal to 1. But also any exponent or any base to the 0 power, like 5 to the 0, is equal to 1. So we want to keep that in mind. When we see 1 in an equation, we can make it any base we want if we put an exponent of 0 on it. And then 1/7. 7 to the negative 1. 6. Oops. 6 to the positive 1. Or 1/6 to the negative 1. All right, so we're going to solve exponential equations using what we know about powers. And that 9 can be rewritten as something to a power, and 27 can be rewritten as something to a power. So our first step is to rewrite both sides with the same base. Now, we're not going to talk about what to do if we can't do this yet. That's like later on in the chapter. It's like the last type of problem we solve. So we're dealing with equations where now the exponent is in the variable is in the exponent. Before, the exponent had the variable, right? Now the variable is in the exponent. So what base can I write 9 and 27 as? I want the same base. 3. 9 is what? 3 to what power?
2.
Squared. 3 squared to the 2x plus 1 power. That's equivalent, right? It has to be equal to what we started with. And 3 squared equals 9. What about 27? 3 cubed. And it doesn't have an exponent, so I can leave that. Now, so this is what we call our critical step. Well, not yet. The next step is our critical step. We want to make sure we're always writing this down before we move on. What do I do with my exponents on the left side? When I raise a power to a power, what can I do to my exponents? I can multiply them. So I'm going to distribute the 2. And I'm going to write that as 3 to the 4x plus 2 equals 3 cubed. Step 2 is to simplify the exponents.
Then step 2 is a critical step.
Yes. And this is our critical step. You will lose points if you don't write this step down. Okay? And it's because when we skip writing this down, we usually make little mistakes. Okay? Now, if the bases are the same, and we say 3 to the 4x plus 2 is equal to 3 cubed, wouldn't it make sense to say that the exponents have to equal each other for these expressions to be equal to each other?
Wait, what? Sorry.
Doesn't it make sense to say that the exponents, 4x plus 2, has to equal 3 in order for these expressions to be the same?
Yeah.
Right? We have to be raising this, if the bases are the same, we have to be raising them to the same exponent in order for them to be equal. So we can equate our exponents, set them equal to each other. Okay, that's step 3. As long as my bases are the same, I can equate, set equal to the exponents. Step 4, can you solve that equation? Yes, solve. How do we solve that?
Subtract 2 on both sides.
Subtract 2, 4x equals 1, divide by 4, and x equals 1/4.
And that's our final answer? We don't need the base?
That's our final answer. Because we know the base in the equation is 3. We want to know what value of x makes the equation true, right? So we're still solving for x. Okay, let's try. So 4 to the 9n minus 2 equals 256. Now, I don't always have to rewrite both bases, okay? If I look at this and say, oh, I can write 256 as a power of 4, then we can just write one side and leave the other, okay? So 256 is 4 to the 4th. So I have 4 to the 9n minus 2 equals 4 to the 4th power.
And since there's no other exponents that multiply times 2, then we just go straight to step 3?
Right. There's no simplifying left to do here, right? I don't have to multiply any exponents. So this is my critical step. On your homework tonight, I want you to highlight, box, star that critical step. Okay? I'm going to look for that. And then what's my equation once I equate my exponents?
9n minus 2 equals 4.
Good. 9n minus 2 equals 4. And then we can add 2. 9n equals 6. Divide by 6. And n, divide by 9. I don't know. Divide by 9. And n equals 2/3. Make sure to reduce your answer. Okay. I want you to try number 3 on your own. Let's do this. What base are we going to use? We have the numbers 3 and 9. We're going to use the base of 3. Do I need to change the left side? No. 3 to the 5x. How do I rewrite 9 as a power of 3? 3 squared to the 2x minus 1 power. Now I simplify. 3 to the 5x equals 3 to the 4x minus 2. So notice we're using our exponent rules that we learned yesterday. When we raise a power to a power, we multiply. Now I write the equation 5x, wait, this is my critical step, so I'm going to put a nice pretty box around it. 5x equals 4x minus 2. And then we can subtract 4x to get the variables on one side. X is negative 2. All right, example 4.
Careful, she'll make it worse. I know, I'm very careful what I say now. Look, she's smirking. Oh, there it is.
Whoa, this looks a little scary, but I think we can handle it. We already have all the same bases, right? But I have more than one power on the left side, so I need to use my exponent rules and make it one power. What do I do when I multiply powers? What do I do with my exponents? We add them. So we end up with, so we're going to add our exponents to simplify. 5 to the x squared plus negative 4x, so x squared minus 4x equals 5 to the 12th. So when you see more than one base, more than one power, you've got to use your exponent rules to simplify it. Okay. So now that's my critical step because I have one base on each side. My exponents are simplified. What's my equation?
X squared minus 4x minus 12.
Equals 12. And then how do I solve that? Subtract 12. X squared minus 4x minus 12 equals 0. How do I factor those how do I solve those kind of equations? I factor. So what two numbers multiply to negative 12 and add to negative 4? Right, x minus 6, negative 6, and positive 2. So x is equal to 6 and negative 2. Now the nice thing about these equations is there's no domain restriction, which means there's no extraneous solutions. Both numbers will work. Okay? We will get to the point where we have extraneous solutions this chapter, but not with exponentials because the exponential function has a domain of all real numbers. Okay? All right, so let's try this one. This one you try on your own. 3 to the x squared times 3 to the 5x equals 3 to the 14. Try this one on your own. Our bases are all the same, so we're going to add our exponents on the left. So it becomes 3 to the x squared plus 5x equals 3 to the 14. That's our critical step. Then we're going to set our exponents equal to each other. X squared plus 5x equals 14. Minus the 14. Remember that we can't combine the 14 with the 5x. It's x squared plus 5x minus 14 equals 0. Whenever we have the x squared and the x in an equation, we want to get it equal to 0, and then we have to use our factoring skills. If factoring doesn't work, what do we have to do? Quadratic formula, right? So x plus 7 and x minus 2 multiplies to negative 14 and adds to 5. So x is negative 7 and positive 2. Okay? I'm going to make this one harder. So we have now 4 to the x squared divided by 4 to the 7x equals 1. What are our rules for dividing exponents? It's an x squared. Subtract, right? When we divide powers, we subtract the exponents, and my bases have to be the same to do that, right? So it's 4 to the x squared minus 7x. Remember that if the denominator is negative, you're subtracting a negative, and that's going to change signs. Can I rewrite 1?
No.
4 to the 0 power. Remember, when I have it equal to 1, I can write it as any number to the 0 power. So I can make it any base I want. 4 to the 0. Now that's my critical step. What's my equation?
X squared minus 7x equals 4 to the 0.
Equals 0. Remember, I'm only taking the exponents.
Oh, right.
How do I factor that? Yes, I just factor out my x. So x times x minus 7 equals 0. It's a common one we struggle to factor. And x is equal to 0, x minus 7 equals 0. Remember, that's what we're doing to get our answers. So x is 0 and positive 7. Okay. Okay, and then I'm going to do one more. Okay, one more example. We haven't done a lot where the variable's in the denominator, right? But first I'm going to rewrite 2 and 32. Can I write them as the same base? 2 can stay, right? Because that's the lowest it can be. But 32 is 2 to the 5th power. So it's already simplified. So what's my equation?
4 over x equals 5.
Right. 4 divided by x is equal to 5.
Don't you multiply by x?
Yes, I'm going to multiply both sides by x to get it out of the denominator. So 4 is equal to 5x. Divide by 5. And x is equal to 4/5. Okay, so what if there's fractions? I'm going to record more. We have 1/9 we can write as 3 to the negative 2 to the 4x. We have to make sure we're writing this expression is equal to what's above it, not what's equal to what's on the other side. And that equals 3 to the negative 3 to the x plus 1. So again, the 3 to the negative 3 equals the 1 over 27. We're not trying to make it equal to what's on the other side, but we want to write an equivalent expression for what's on the same side of the equal sign. And so now I can multiply my exponents. 3 to the negative 8x equals 3 to the negative 3x minus 3. Make sure we distribute. And then that's my critical step. And then I can set my exponents equal to each other. Negative 8x equals negative 3x minus 3. Now we'll get our x's together. So plus 3x. So negative 5x equals negative 3. Divided by negative 5. And x is 3/5.